Hello viewers, in today's class we are going to discuss yet another important and conceptual problem from integrals involving the greatest integer function and the absolute value function, which is also known as mod function, right? So here we have the integral from 0 to pi by 2, and the integrand is x times the mod of x minus and the square of greatest integer of sine x, right? So let us solve this problem by making use of the concept of absolute value function and the greatest integer function, right? And here we'll also see the graph of sine x from 0 to pi by 2, and we'll see the value of greatest integer of sine x when x varies from 0 to pi by 2. So let us start. Now let us first call this integral as I, right? Now here we can write this integral as a sum of two integrals. So we can write it like this: 0 to pi by 2, and here we have x mod x dx minus 0 to pi by 2, and then we have the square of the greatest integer of sine x, right? Okay, now here we have to evaluate two integrals, right? So we'll take the integrals one by one. So let us first take this integral. Now here we can take this integral as I1, this integral as I2. So we have I1 minus I2, right? So we'll first consider I1. So I1 is from 0 to pi by 2, and we have x times the mod of x and dx, right? Now see the value of this absolute value of x is simply plus x, because mod of x is equal to positive x whenever x is greater than 0, right? And mod x is equal to 0 whenever x is equal to 0, and this is equal to negative x whenever x is less than 0, right? So this is the definition of the mod function, right? So here we see that the limits of integration varies from 0 to pi by 2, right? And when x belongs to this interval, that is 0 to pi by 2, all the values of x are positive, right? Obviously all the values of x are positive when x belongs to this interval, that is from 0 to pi by 2, right? So x is greater than 0 in this interval, that is 0 to pi by 2. So we'll take the definition of mod x as equal to plus x, right? So now here what we will do, we'll take 0 to pi by 2, and here we'll have x times plus x, right? Because mod of x is equal to positive x, because x is greater than 0 in this interval. So now we have a very simple integral. So we have 0 to pi by 2, and here we have simply x square dx, and the integral of x square is x cube over 3, and the limits of integration are from 0 to pi by 2, right? Now we'll simply substitute the limits. So here we have pi cube over 2 cube is simply 8, and here we have 0. So now we have pi cube over 24, right? So 3 is 24. So we have obtained the value of I1 as pi cube over 24, right? Now let us solve this integral I2. Now I2 is integral from 0 to pi by 2, and we have the square of the greatest integer of sine x, right? See, now we have to assign the value of greatest integer of sine x when x varies from 0 to pi by 2, right? So to assign this the value of greatest integer of sin x, let us have a look at the graph of sin x, right? So here we'll have the graph of sin x, and this is y-axis. So now we can draw the graph of sin x like this, right? So we are just taking the graph from 0 to 2 pi, right? And now here we have pi by 2, right? And we see that when x varies from here we have minus 1, right? So we see that when x varies from 0 to pi by 2, the value of sin x, it varies from 0 to 1, right? So it goes from 0 to 1, the value of sin x, when x varies from 0 to pi by 2, right? So therefore the value of greatest integer of sin x would be always equal to 0, right? When x varies from 0 to pi by 2, right? Because the value of sin x varies from 0 to 1 when x varies from 0 to pi by 2. So therefore when sin x lies between 0 and 1, the value of greatest integer of sin x is obviously equal to 0, right? So here we have 0. So now the integral becomes 0 to pi by 2, and here we have 0 square dx, right? So the value of this integral is 0, right? So now we have I2 is equal to 0, and the overall value of the integral I is I1 minus I2, and I1 is pi cube over 24, and I2 is 0, right? So we have pi cube over 24, right? So the value of this integral is equal to pi cube over 24, right? So here the important thing is to assign the value of mod x and the value of greatest integer of sin x, which is equal to 0 whenever x belongs to 0 to pi by 2, because the value of sin x lies between 0 and 1, right? And the greatest integer of sin x is obviously 0, right? So this is how we solve this type of problems.